Okay, so welcome back to the final session of this afternoon, and to kick us off this afternoon is Angus Hewlett from F-Expansion. Angus, rather than working for a university research organisation, is going to be talking more about industrial strength software, of how some of the research software that have been used as part of products is made so that it's reliable enough for real use in the real world. So Angus, over to you.
Thank you. Yes, I'm founder and one of the developers at F-Expansion. We're a company building software for musicians, producers, sound engineers, and in order to kind of stay ahead of the game, we've been deploying a lot of research-driven software in various different ways that's had its origins in places like the Centre for Digital Music. There's been various kind of collaborations we've been involved in, so I just wanted to share kind of a few kind of experiences at an abstract level from some of that. So, what is software? Is it a means of communication, or is it an actual working bit of machinery? Well, it can be both, and in most fields of human endeavour, you know what you're looking at. You know whether it's a napkin sketch, whether you've got a blueprint, or whether you've got the actual finished article. With software, sometimes it's not clear looking at someone else's code what they were setting out to do there, and sometimes I think people aren't even clear entirely themselves on what they're doing. So if you're looking to have your software used in industry, the first thing probably you need to be thinking about is, well, what are you trying to accomplish? And this is kind of thinking in terms of industry as being your customer. Now, I've shaded these kind of 4 stages to kind of indicate how the responsibility can be shared between a researcher such as yourselves and one or more companies. The first one there, you're doing everything kind of from the start to the end, bringing something right to market and selling it to consumers, which certainly you can do. Second is a pretty common model where you're building an implementation that is, at least in theory, fully working, and then licensing it to a company who then package it for customers. The third model, you're certainly building a prototype and then more licensing the IP from that to a company who then build it. And the fourth one really is just not going beyond the conceptual stage, maybe just publishing a paper, and industry kind of picks it up from there. So the 4 stages: you've got the concept, which is the core of your idea. That might be expressed just as maths, it might be pseudocode, it might be high-level language. It may not be something you can run and actually execute and give to someone else and go, here's my thing, use it. It's earlier stage than that. Prototype is something that works. It may not be built in a language that can actually be used in a commercial product. It may be too high level for that, but you can use it. Now, if you are building a prototype, then really the code you're writing should be about expressing your idea clearly for yourself, for other people in academia, and for anyone in industry who you might be hoping is going to use it. I'll say a bit more about that a bit later. Implementation stage, it's more refined, it's strengthened, it's going to be built in a medium or a low-level language, very often C++ or Java, but not necessarily. It's also going to be specialised towards the customer's domain requirements, which I'll say a bit more about later. Rather than kind of drilling into things that are specific to my sector in industry, it's across the board. Every sector has got its own specific requirements, and whatever they are, you need to be aware of them. And then robust and high performance. I've put those in quotes because depending on the industry, they may have very different expectations as to what robustness and high performance actually mean. I mean, I can tell you the defence industry, for instance, have very different requirements to 2-bit software companies in London Bridge. But it's got to be good for whoever the customer's going to be. And then the final product is really to encompass everything else: system integration, GUI, user documentation, packaging, and then you can't bring a product to market without having all the other stuff as well, like after-service customer support and all sorts of business administrative functions that actually let you run that as a kind of business you can stand behind. So to recap, we've got these 4 different models for bringing your idea to market. We're going to focus on the ones in the middle today. The 4th one I think you probably already know how to do, and the one on the left hand side there, number 1, I'm not going to say don't do it. By all means have a go. It's what I did. I think it's great. It can be incredibly rewarding. It can also mean spending an awful lot of time and energy and effort on things that have nothing whatsoever to do with your research. So if you don't have a lot of patience for some of the other stuff that goes with running a company, then find some other people that do. So if what you're looking to do is build a prototype for industry, what you're really thinking about there is in terms of knowledge transfer. So you're helping somebody else to build a version of your idea. You should be expressing that in a language you're confident with. Don't decide to build a prototype in Objective-C just because your customer uses Objective-C when you don't know it very well. It's much better to build it in a language that you understand well, that you can express yourself well in, but do so with an eye to whatever you think the implementation domain is going to be. If you think this is something that's going to end up in toys, then learn about the kinds of microcontrollers that end up in toys and what sort of restrictions they might have. If you're looking to license it to small commercial developers, don't use any libraries that cost £40,000 for a commercial license, because it's not helpful. So look at CPU capabilities. Does the chip you're thinking about or your customer might be thinking about, does it have floating point? You know, this is stuff that you really need to be thinking about even designing a prototype, because if you're heavily relying on FFTs and their hardware won't do FFTs, or they haven't allocated enough of the CPU time on the console they're doing to do audio stuff, then your prototype might not ever actually translate into something they can use. The advantages of this model, really, it lets you play to your strengths. You're not having to learn lots and lots about software quality assurance and about the very specific requirements of industry. You can keep doing kind of what you're good at. It's a kind of smaller upfront investment. You haven't got to totally productize the thing. You are teaching a man to fish. So once you've transferred this knowledge over to your kind of industrial partner, they know about it, they can use it, they probably won't hassle you again about it. And there's domain flexibility. Because it's not the final implementation, it's not going to be kind of finely dialed in for the requirements of a specific niche industry, when there might also be an opportunity to license the same thing to the next industry over in a slightly different niche. Disadvantages, it's not as reusable, because with every new client you want to license to, you've got to then kind of put the time in to get that knowledge transferred to them, which is typically going to be going and working in some sort of partnership with them for several months at a time. You've got the kind of longer initial engagement with each of your potential clients. There are some potential IP issues there, because you're basically teaching an industry partner everything that you know about this thing. You've got to be really careful with IP licensing, and that might mean patents. That might mean just having a very clear understanding of what belongs to who and what they're allowed to do with it. You've got to be kind of careful with IP, because they've got it all at that point. It also can be more work to actually find customers for this sort of model because they've got to do more work to actually get it incorporated into their product. So, you know, if you've got a prototype of something great and you go around a bunch of music software companies and say, hey, look, you know, I've got this great thing, it works really well, but it's going to take you 6 months to implement, people are going to kind of think long and hard about where that actually fits into their kind of product life cycles and that sort of side of things. So it can be a bit more work to actually sell it rather than saying, hey, I've got a Windows DLL, you can plug it straight into your code and it'll be a new button, a new feature in your bit of software. So the other approach, building solutions for industry. If you're going to do this, you need to have a really solid understanding of the customer's implementation and domain constraints. You know, each kind of niche in industry, like I say, has specific requirements. I'll talk about some of these in a little while, but each industry's got their own, and if you want to sell to a specific industry or a specific niche, you need to kind of know what those are. And even better, if you can understand their customer a little bit. I mean, we sell stuff to, like I say, musicians, producers, audio engineers, and if you understand a little bit about our customers, then our sort of requirements for a bit of technology we might want to license make even more sense in that kind of context. And you've got to basically practice a very high standard of software carpentry, which Luis is going to be talking about a bit after this. It's not necessarily software engineering, but good practices to build solid, reliable, trustworthy software. At this point, we're really, in industry, a customer for something that you are selling as a solution. So if it causes more problems than it solves, you know, we're not going to be happy customers, I guess. So some of these sort of essentials, there's some universal things to think about there. I would hope all of these are fairly obvious in the first set. Things like well-defined APIs, good error handling, documentation. Then domain-specific ones are very domain-specific, but common ones that will kind of come up would be things like library availability. You know, does your potential customer actually have all the libraries that you've been using to build this? Execution time guarantees. That doesn't necessarily mean it's always going to finish in a set number of microseconds, but guaranteeing some sort of range of CPU cycles, or that it's not going to trigger big uncertainties, things like priority inversions, or there's all kinds of potential issues there when you're writing high-performance code that can really sort of slow things down. Completion guarantees, can you prove that a bit of code will finish executing? Some industries demand that code can be mathematically shown to complete, that it'll never go off into an endless loop. We don't, but some do. So yeah, it's really about knowing your customer, knowing the industry and the sector that you're targeting, and also being aware of whether they are going to be able to use your product. I mean, this is something that we think about a lot, building things for end users, is, well, is this something that that a musician or a producer can actually use? And that's a big kind of discussion for us. Similarly, if industry is your customer, you have to say, well, are these guys in industry going to be able to use this thing the way it is? Is the documentation and the overall package, does it actually meet their needs? Will they be able to understand it and implement it? What are their constraints? Can they afford to spend 3 weeks integrating it, or do they need to be able to get it up and running in a day? This kind of thing. And just, is the project going to work for them? Because if it works for them, they'll come back to you and work with you time and again, and if it doesn't, they'll probably go somewhere else. So big part of that is making sure you've got something that's high quality. You can do various kinds of testing, unit testing, automated tests, TDD, which is test-driven development. You actually write the tests first and then develop the software to pass those tests. beta test, this is almost a bit of role play, really. You know, you are looking to make something available to a customer, so have one of your colleagues pretend to be that customer. They're approaching your product, your API, blind. You say, write something that uses my API. I'm not going to help you any more than just use the documentation available and see how they get on with it. And if they can do that successfully, then that's a pretty good test. And then public beta, we do this quite a bit when we have new software out the door or big kind of changes. We'll release a version to the public or to some of the public, which is not fully test guaranteed, and those that help us out on it kind of get some concessions, so they might get a free copy of the next version or that sort of thing. And that's one thing to think about is, you know, if you're looking to sell something to 8 companies, maybe the first one you say, okay, we've not sold this thing before, there might be a few bugs, but we'll let you have it for half price if you report bugs to us, that kind of thing. So with this overall approach of trying to provide a full kind of working solution, the advantages are, if you get it right, it's an easy sell over and over again. You look at how many people have licensed, you know, something like the Fraunhofer codec. You know, they've licensed that, I don't know, thousands and thousands of times, and it's one piece of code essentially. It's an easy sell if it solves a problem that people know they have. It's a lot more work than just building a prototype, and if you put in all this extra work building something that people don't want, then that can kind of be a lot of wasted effort. So you kind of want to be sure that you're building the right thing. It's a fairly kind of short initial engagement with the client. You know, you're showing them something that works, agreeing a contract, and handing it over, and they can get on with it, really. And there certainly can be fewer potential IP issues there. You're licensing them a piece of software. As long as you get a halfway competent lawyer to draw up a license agreement that kind of agrees with your basic understanding of the deal, then really there's not much scope for sort of the messing around there, although it depends a little bit on the source code model. Disadvantage, like I say, you're doing a lot more stuff that is not really your kind of core area of expertise. You're having to learn all this other stuff to turn it into something resembling a product, and that might require actually putting together a business case first to say, well, is it worth me spending 6 months of research time on, let's face it, boring productization work? Is there a business case that actually justifies you spending that time? Recurring maintenance, there's nothing that moves like a platform when it's an operating system. I mean, the last 15 years, the number of changes we've seen where we've had to kind of recompile all our libraries and go back to people we've licensed code from and say, look, this just isn't working quite right on, I don't know, 64-bit Mountain Lion or something like that. You know, this happens kind of time and again. So even though you've sold it, you haven't necessarily got yourself completely off the hook, and people may come back to you years later and say, actually, can you just recompile this or fix that? And then you need to think very carefully about the source code model that you're following, whether to go open source, whether to, you know, which does then still have some IP issues, or whether to go closed source and not send your client the source code, in which case your quality assurance had better be tip-top, because when they're beta testing, if our program crashes in your code and you haven't sent us the source code, we're just going to be a bit of a pain about that, really, because we can't see what's going on and debug it and fix it ourselves. So you've got to make sure that all the bugs are out if you're not going to send people the source code. Equally, if you do, there's still some potential for IP leakage there. If that all sounds like a bit of a big plateful, then you can look at outside help. There are certainly, these are two companies, Z-Plane Development and Isotope, who have kind of made a business out of bringing research, basically turning research-based code into solutions for industry. Obviously, they're going to take quite a cut for that, so you know, there's that kind of that side to consider. But you can basically take a prototype to them. If they think it's worth commercializing, then they will do a lot of that work, and they understand a lot of the industry-specific domain stuff, so that you don't have to. So that's certainly one way to go. So really, you need to think in terms of solutions. If you know that industry's got a problem that we want solved, then that's the right kind of you're on the right track, building something to solve it. Know your capabilities and your customers' capabilities. If you don't know how to write a piece of thoroughly debugged software, then it's not a good idea to sell something you've made as being a thoroughly debugged piece of software. Similarly, know your customers' limits in terms of how complicated a thing they can integrate. Some of us have a lot of patience, and on some projects we just don't. Practice good software carpentry. And finally, industry experience counts. If you get any opportunities to spend 6 weeks at a company in the sort of industry domains you're interested in, then go for it, because understanding how they work from the inside is just extremely valuable if you're trying to solve their problems. Thanks very much.
Okay, thanks very much, Angus. Any questions? First one, David.
Yeah, you talked again about software carpentry standards that you've kind of got. I wonder if you've kind of got a house style for that, and if you made it available to people who are potentially interested in working with you or providing solutions for you, so they could work to your house style.
We don't require outside people to write to our house style. That's not. If we're getting something in from outside, if it was coming in as a sort of knowledge transfer project where we were rebuilding it, then we'd have like a developer sitting with the researcher, kind of rebuilding it in C++ to our house standard. But if we were licensing in outside C++, as long as it's written to a standard, and as long as it acknowledges some of the sort of domain-specific stuff that we have to deal with in our particular sector, which is things like very deterministic processing times on the audio thread, so we're not allocating memory in the audio thread because that can block and get glitches in the audio stream. But it's all gets very, very specific, but we don't particularly expect other people to stick to our standards, just as long as they have standards and stick to their own, really.
Brian, you have a question.
Sounds like my big takeaway from this is don't do anything. In general, researchers probably should stay away from stuff beyond prototyping because it gets too hairy. Would that be a good rule of thumb for us?
Not necessarily, no. I mean, researchers who don't want to do anything other than research should maybe stop at the prototype stage and hand it over, but I think it can be very rewarding to be involved in the industry at sort of on multiple levels, whether that's as a kind of commercial developer taking an interest in the academic side, or an academic developer who decides they want to go it alone and productize their work. I think that can be a very rewarding thing to do, but I think you need to be you need to kind of try and be honest with yourself as to where you're at, I suppose. But it's something I'd encourage.
Okay. And time for one more quick question, I think. Very well. No? Oh, okay.
Well, I would just say supplementary to that, I think it's good from the point of view of someone in a research environment, overseeing the whole process of how this thing does get turned into a commercialised product, and having the experience of seeing what the industry requirements are, so that they're better informed for the next bit of IP that they produce, and then they're much more able to be able to approach industry partners and say, here's our algorithm, we satisfy all these complexity guarantees, and our code reaches this particular standard, and we know the sort of thing that you're looking for. So I think it's good experience for researchers to have, having been through it once.
Yeah, I think that's spot on.
Okay, all right, one last.
I think that related to that as well is, university technology transfer departments are going to prefer if they can, presumably, to take code that some researcher has just done on their own and then flog it as something that's finished. In other words, they're going to want to kind of skip all that stuff, aren't they? How do you actually make it happen if you're in a case where a university is wanting to take something you've done and make it sell it as quickly as possible?
Well, I mean, if it's not finished, then really industry are probably going to want some of the person's time as well as the code. If it is finished, then you kind of need to make sure it's finished to a high standard. And just trying to, I think it's dangerous when people try to flog something and they don't really understand what it is or what state it's in. That's probably a recipe for problems.
Okay, thanks very much again.